Okay, Karthik, you answered to the two questions. What is your average speed? Come on, dude. You want to drive this car and you can't tell me what your speed is? 100 what? Okay. And what's your instantaneous speed? Okay. Don't do this on mission, okay? All right, let's do it on mission to the north of this place, okay, not south. Yeah, north of Mission San Jose. And so what if your needle's not it's not stuck there, it's not like, you're not steady, right? Okay, it's kind of jittering because of whatever reason, maybe your lights or a cop, you just saw a cop and you kind of hit the brakes or something. So then you have instantaneous velocity. In other words, if you look at the speedometer, it might read 98, and then a second later it might read 102. Okay, so instantaneously it's changing. Okay, instantaneously it's changing. Okay? So we want to talk about two concepts today, okay? Average velocity and instantaneous velocity, okay? So take a look at this graph here. I'll pause for a minute. Formulas in here. Okay, I'm getting there. Okay. There is this formula here, okay? Average velocity. And then there's another formula here, which is instantaneous velocity. This thing might not be very obvious to you. It probably doesn't show up does it show up clearly there? No, not really. This is really f prime of t. Does everybody understand what f prime means? What does f prime mean? Monica, nice hair. What does f prime mean? She's doing her hair, man, so whatever. Is ooh, you know more than hair. Nice. Okay. It's the derivative of f. Okay. So the graph that we are looking at is this one here. That's your distance function. Okay. That's your distance function. So your distance is on the y-axis. Time is on the x-axis. Okay. Need I explain the average velocity equation to you? It comes straight out of distance over time. Okay. From your physical science in what? 7th grade? When do you do physical science? 8th grade? Okay. Distance over time. Okay. And to find the instantaneous velocity, you need to differentiate a function that's given to you, okay? And let's do an example and I'll show you that in a minute. You guys got this down? Yeah. Okay. So we all right there? Okay, so I want to do example number 9 on page 113. Okay, so can you please get your books out on that? So your distance function s is equal to negative 16 t squared plus 100. All right. So there are 3 parts to the question. I'll do one of them and then you guys can do the others. Notice that the example is just asking you to find the average velocity between 3 different intervals. But then I'm asking you to find the instantaneous velocity at these different times, okay? At these different times. Okay? So I've added to that question. I've added to that question. So if you want the average speed, okay, you're going to do, for part A, you're going to do S2. Does everybody understand what S2 means? Sorry? Sorry? Can you be a little bit more explicit than that? What does S2 mean, Michelle? What is it? Sorry? Exact, for T. Not for S, but you put 2 for T in S. Oh, get it? 2 for T in S. Okay? Minus S1 all over 2 minus 1. Does everybody get this? This is right out of that average velocity formula that I gave you. Change in distance over change in time. Now you guys know how to do this nicely on your graphing calculator. What would you do? What's the first thing you need to do? Yeah, turn it on, be a good idea. Yeah, okay. And then you need to put the function in y1. Okay, put the function in y1. And then this is how you want to do it, okay? If you want to do the average speed stuff, you're going to go parentheses, vars, y-vars, function, y1, and I'm evaluating it at time 2, minus vars, y-vars, function, y1 at time 1. Parentheses, be careful with the parentheses here, okay, because someone in the last period didn't put it correctly and didn't get the right answer, okay, and had no clue as to what was going on that one. Divide by 2 minus 1. So that gives me negative 48, and the units on these are the units for distance are in feet and time is in seconds. So your answer should be negative 48 feet per second. Okay. Can you guys do parts B and C then? Do parts B and C. And make sure you get the answer that the book has. Okay. Yeah. Did you do B and C already? You got error? You be smoking. Did you put parentheses in properly? Did you put the right equation in y1? Well, I guess I'll have to. All right, so what I want to do now, okay, Henry, what I want to do now is do the instantaneous velocity. Okay, I want to do the instantaneous velocity. What do I need to do for that? What do I need to do for that? It's not there. It was in my slide that I showed you. I gave you 2 equations with that graph. What do I need to do for that? Find the derivative s prime of t, and what is it? Negative 32t. And if you want it at 1 second, what's it going to be? Negative 32 units. Units. Feet per second. And to get it at 1.5, yeah, negative 48 feet per second. And at 2, negative 64 feet per second. Okay, the bottom line in this lecture is the difference between average velocity and instantaneous velocity. Do you guys get the difference? Do you now know what to do between the two? Jonathan, what do you do for average? Yeah. Well, can you give me in words what average would be? In words. Change in distance over change in time. I think this should be one of the driver ed requirement questions. Seriously. If you don't know how to compute your speed while you're driving, just in case you've got a bum car like me where the speedometer doesn't work. The Lexus speedometer is kind of... Yeah, but the Lexus speedometer is kind of... Sorry? Yeah. Don't I look green to you? I don't look green. Yeah. Yeah, that's right. I mean, you should know that. Okay? And then for instantaneous velocity, does someone want to give me things in words? For instantaneous velocity, does someone want to give it to me in words? Sorry, say that again. Find the derivative of distance curve. Distance time graph. Okay? That's all I need to teach you today. That's it. Okay? That's it. Are you disappointed in it? You want to continue?